We're going to continue today talking about our six trig functions and their relationship with each other and the unit circle. So let's start by doing the following. We're asked to name the quadrant or quadrants where the conditions below exist simultaneously. So let's look at this one first. We need to know where the sign value is less than 0. Sign indicates the y value in a unit circle. So those guys are over here, all below the axis. And the cotangent value is the division of the x and the y, and that's got to be a positive number. So that will be in the first quadrant and in the third quadrant because negative and negative is a positive. So where they both exist at once is in the double hashed region, so that's quadrant 3. Secant is greater than 0. Secant is just the reciprocal of cosine, but we're still looking for a positive cosine value, so that'll be quadrants 1 and 4. And then sine, which is just the y value, is going to be greater than 0. We're right here, so that's quadrant 1. We've done problems similar to this, but not quite the same in actuality. Okay, they say we want to find the cosecant and the tangent. So the cosecant is just the r over the y value, and the tangent is just the y over the x value. Given that theta is in the standard position, so that means we start here, and it has a point on the terminal ray of -4, -7. -4, -7 somewhere down in this quadrant. And that's going to make a reference angle right around here. And with an x value of -4 here, a y value of -7 here, we can do the tangent right off the bat because that's just y over x. So 7/4 is the tangent value. The cosecant, I'm going to need a radius to do that. So again, we have a Pythagorean theorem working right here since that's our right triangle. So that's -4 squared plus -7 squared, all square rooted, will equal our radius. So that gives us a 49 and a 16 added together. That is 65 rooted. So we need our r, which is root 65, over our y value, which is -7 in this case. So we'll do some similar problems to what we just did, except for the fact that it's going to be phrased differently. They're telling us the cosine is 4/9, and we have that angle existing in quadrant 1, and we want to find the sine value. So let's just draw a makeshift set of axes right here and draw an angle over here, theta. And that angle makes us a right triangle. When they tell us the cosine is 4/9, I could say this is a unit circle and put 4/9 right here. However, in problems like this, I prefer not to because I also know the cosine has a relationship of the adjacent, or the x value, over the hypotenuse. So I'm going to term it this way and say, hey, this is just a triangle of hypotenuse 9 and a circle of radius 9. Then it has an x-coordinate of 4. I can find my y-coordinate, which I need to find the sine, because sine is just the opposite, which is y over the hypotenuse. It's the sine of theta. So I'll do that. I have 81 equals 16 plus y squared. I'm going to take and subtract that. So I'll get a 65, right, is y squared. And y is equal to the root of 65. Since I'm in the first quadrant, that's got to be a positive. So the sine value then is the y value, or root 65 over 81. So we have the same example here, except we notice that we have a -3/5 as a sign, which basically means either 3 could be negative or 5 can be negative. They both can't because then it would be positive. So again, if I choose to draw another circle, which I think I'll do, and put in my axes, I know that I have a sine value of -3/5, and that value has to be somewhere between pi over 2 and 3 pi over 2, which is in this area of the circle. The only way that's going to happen is if we're down in the third quadrant, because that's the only place where the y value can be negative. So I'm going to call this guy a -3 and this 5, and I have an unknown x value for my reference angle of theta. Now, we know that since we're trying to find secant, we're looking for the hypotenuse over the x value is equal to the secant of theta, because that's a reciprocal of cosine. So now all I really need to do is find the x. I have 25 is equal to 9 plus x squared. This will be 16 is equal to x squared. And then square root that, so x is equal to 4. However, since I'm in the third quadrant, I have to have a negative. Remember, when I take the square root of both sides, I'd have actually plus or minus 4 is equal to x, but I only use the negative since I'm in the third quadrant. So again, my hypotenuse in this case was 5. My x value is 4. I can put the negative here, or I can put it out here. Again, similar problem. Draw your circle. Draw your axes. I've got to find my sine, so that's y over r. And then I know I have a cotangent, which is just the x over the y value. And they say I have to have an angle somewhere between pi and 3 pi over 2, which is in the third quadrant. So again, I'm going to go over here. But I know the x and y in this quadrant are both negative. However, if the cotangent value is positive, that just means I can have two negatives, because a negative over a negative is going to be a positive. So -15 and 8, 15, 17 is going to be a Pythagorean triple, so I know that this is 17. Therefore, my y value in this case is -8. My r value is 17, and there's my sine. So now in this problem, they're telling me I have a secant value that is positive, which means x has to be positive, so I'm either in the first or the fourth quadrant. But they tell me the tangent value is negative, so I have to be down here. I have a secant value, which is the hypotenuse over the x, so root 35. So hypotenuse, my x is 5. And they're telling me that the cosecant is unknown, and I need to find that. Again, cosecant, hypotenuse over the y. So I'll go ahead and find that. I have 35 is equal to 25 plus y squared. 10 is equal to y squared. And plus or minus root 10 equals y. So in this case, you'll notice that where y has to be negative, so negative root 10 is equal to the y. Therefore, I have root 35 over 10 of the negative type is going to be equivalent to the cosecant. Probably got to clean that up, so that's root 7 over root 5, and rationalize that. And I have root 35 over 5 as my solution. And that's all there is for today. Until next time.